Today's lecture. I'll give you the KVL, Kirchhoff's voltage law, and then after that I take a roll and continue. We are getting close to exam 1, and I have to finish chapter 2 before exam 1, even maybe part of chapter 3, but that's why, and chapter 2 is the main chapter because it covers main laws, main circuit laws, including KCL, KVL, and Ohm's law. Last time we talked about KCL, which is the current law, and the summation of currents entering is equal to the summation of the currents leaving. Okay, we talked about circuit law. Today, I'm going to talk about Kirchhoff's voltage law. Kirchhoff's voltage law, or KVL. But before doing that, do you have, at the beginning of my lecture, do you have any question?
Yeah, I have one question. So, like on Telegram's theorem, you know, when we put the absorb equals supplied, so the sign, do we still use the negative sign?
No. If you use equal, you don't. You put absorb on one side and delivered on the other side. But if you put all of them on one side, then absorb is positive, delivered is negative. Then you have to use the sign. So for example, if you have P1 equal to, let's say, 40 watts absorbed, and P2 minus 40 watts, this is absorbed, this is delivered. If you want to show suppose you have only two power values. So if you want to show the power conservation law, if you put them on one side, then you have 40 minus 40 equal to 0. However, if you want to say absorbed equal to delivered, we just say 40 absorbed equal to 40 delivered. Okay. Anytime you write algebraic equation, if you put all the values, all the elements on one side, then you have to follow the plus minus sign. But if you use just like a current entering, current leaving, remember last time I said if you put all the current entering on one side and the current leaving on the other side, you just have I1 plus I2 equal to I3 plus I4. But if you put all of them together on one side, then you have to follow the sign. Okay, let me discuss KVL, the voltage law. Kirchhoff's voltage law, and please pay very close attention to Kirchhoff's voltage law. Please make sure to mute your microphone because it's creating noise in my earphone. For Kirchhoff's voltage law, some people, they remain very confused about this one, even though it's a simple concept. So please pay attention. I don't mind at this point if you ask many questions. But after this point, after today's lecture, if you clarify all your questions and everything and you practice problems, then you should be fine with KVL. Okay, in order to show you KVL, I'm going to use a typical circuit with bunch of elements or branches. Let's just use one loop. KVL you apply to a loop. It can be a physical loop, non-physical loop, simple loop, combined loop, doesn't matter. Loop, a closed path, any direction. You can move in clockwise direction or counterclockwise direction, doesn't matter. but you go around a loop. Okay, for KVL, you must show voltage symbol or voltage notation if it's not given, and polarities. Without polarities, you cannot apply KVL. If polarities are not given, you apply. It doesn't matter. So don't waste your time to think what's a good polarities. Remember, we did suggest passive sign, non-passive sign. But even if you don't follow that, that's okay. At the end, minus sign and plus sign justifies polarity. Choose any polarity, move in any direction. Even if you have multiple loops, for one loop you can move in clockwise direction. For the second loop, you can move in counterclockwise direction. You have open hand, an option for almost everything. But once you start, you must follow the guideline. Okay. When you moving, if you hit the element going from plus to minus, regardless of value, don't worry about the value, plus minus. This is called voltage rise. Oh, sorry, voltage drop. If you're moving and you're going from plus to minus, this is called voltage drop. If you're moving, going from minus to plus, this is called voltage rise, regardless of value. So anytime you're moving along the loop, when you hit the element, you either go voltage drop or voltage rise. Let's say we have element A, B, and let's use numbers. Element 1, 2, 3, 4. Let's apply polarities, any polarity. Let's call this one V1. You must have, if it's not given, you have to assign. Minus plus, I don't know, plus minus V2, minus plus V3, plus minus V4. And don't look at the numbers. V1, V2, V3, V4, they can be either positive or negative. Don't look at the values. Just pay attention to polarities. Choose a direction, any direction you feel comfortable. Clockwise, counterclockwise, doesn't matter. So let's move in clockwise direction. Start from a point, return to the point. You must cover the loop. Okay, let's start with element 1. When you're passing through element 1, it's a voltage rise. When you're passing through element 2, it's a voltage drop. When you're passing element 3, it's a rise. When you're passing through element 4, is drop. KVL simply is a summation of voltage rises equal to the summation of voltage drops. So in this case, put rise on one side, drop on the other side, doesn't matter which side. Let's put rise on the left, drop on the right. So V1 is a rise, then V3 is a rise, equal to V2 is drop, V4 is drop. Notice that it doesn't matter if V1, V2, V3, V4 are positive, negative. Next, you plug in values according to plus or minus. But your rise, fall, or rise or drop decision is based on 100% purely based on polarities, nothing else. Any question?
Professor?
Yeah.
What if you, after this point, what if you get a negative answer? Does that mean that your loop should have been the opposite way
Not
around?
the loop, not the loop. Polarities. Answer, like for example, suppose you end up, for example, V3 equal to minus 4 volts. It has nothing to do with the loop. It means that V3, when you assign with polarity minus up plus down, actually up is higher potential at down. Minus indicates which end of the element has a higher potential or lower potential. Has nothing to do with the loop. Why do you think it's related to the loop? It's a number. It's the answer for V3 only. Let's say you end up with V3 equal to -4, V3 equal to -4. Do you need to do anything? No. It's just your reading of the information. How do you read -4? Potential at the negative end, because of minus sign, is higher than the potential at the positive polarity end. That's your interpretation.
Thank you.
Any other question? Okay. In textbooks, when they define KVL, they also do it this way. In many books, they do it this way. Regardless of value being greater than 0 and less than 0, only due to polarities. Only due to polarities. When you're moving, it's up to you. You can assign plus to rise, minus to drop. Or you can assign plus to drop, minus to rise. Okay. What happens? It means that you go around and write everything on one side. If you use this format, let me make it red color for this format. For this format, any rise you see, put plus in front. So number 1 is rise, plus V1. Number 2 is drop. For drop is minus V2. For 3, it's rise. For 4 is drop, equal to 0. So you put everything on one side. Notice that this is equation. If you take V2, V4 to the other side, you get this one. What about if you use this arrangement? If you use this arrangement, okay, again, go around. Anytime you have drop, put plus. Anytime you have rise, put minus in front, regardless of value. So V1 is a rise, minus. V2 is a drop, V2. V3 is a rise, minus. V4 is a drop, V4, equal to 0. Again, if you take V1, V3 to the other side, you get the same thing. So this is okay. This is okay too. Because it's algebraic equation. So you have the option of saying rise equal to drop, or rise with plus in front, drop in minus in front, all of them algebraic sum equal to 0, or rise minus, drop plus, algebraic sum equal to 0. Any question?
Professor? Hello?
Yeah, go ahead.
So the only reason that you could go vice versa is due to the fact that it's a summation, right? And
yeah, it's a summation equal. It's equation. In mathematics, anytime you have algebraic equation, it doesn't matter if you take term from left to right, right to left, doesn't make a difference.
Okay, thank you.
Okay, let me take hold by going around and asking a question. This time I have enough time to involve everybody because I want to make sure that you have a good understanding of KVL. So I don't let you go without knowing KVL, because that's very important part of your understanding. Okay, KVL and KCL, I'm going to give you 2 examples. Example 1, and then I'll ask people example 1. Simplifying series voltage sources using KVL. Okay, I give you example. I give you 1 example, and then I'll go around and ask you a question. Suppose I have Dependent or independent doesn't matter, but I'm going to use independent. Plus or minus 4 volts, a box here, minus plus 6 volts, maybe another box here, a plus or minus 10 volts. Okay. Voltage sources are connected in series. Series voltage sources can be combined as one in order to simplify circuit. However, you have to determine how you want it. Okay. Use one source as a reference. You can choose any of them. For example, I'm going to use this one as a reference. It's optional, unless if it's given in the problem. This is my reference. Okay, for the reference, choose direction, any direction to move. So for example, from reference, any direction you want to move, I use clockwise direction, doesn't matter. Again, it's algebraic. Okay, look at your reference when you start moving. You go from minus to plus, it's a rise. So your reference is a rise based on my choice. Okay, for rise, assign plus. For drop, assign minus. So whatever direction you choose for your reference, assign plus to that. And for the opposite polarity, use minus. Okay, so let's do that. I'm starting from my reference here. It's a voltage rise. So I have plus 6. Then I go and hit this one, 10 volts. It's a drop, minus 10. Continue, don't worry about the boxes. You only focus on sources. Then you hit 4 volts. It's a voltage rise, plus, oh, I chose bad numbers, sorry. Let me change 4 to 14, okay? Because I don't want to get 0. Yeah, I get 0. Let's change this one to 14. I don't want 14 volts. Okay. So you start, this is your reference. Rise, plus 6. Drop, minus 10. Rise, plus 14. Okay, simplify. Don't continue. Don't set equation or anything. Just put the values and simplify this number because there is no more voltage sources here. Simplify. You have 20 minus 10 equal to 20 volts. Okay. Now go to this graph. Eliminate everything. Change this number to 20 volts. So your circuit is now reduced to a box here. You can even, because it's a series circuit, you can relocate your voltage source. A voltage source minus plus 10 volts, a box here, and everything else.
Did you say it's 20 minus 10?
Yeah, because this is drop.
Wait, but doesn't it 10 volts?
It's a rise. Your reference is a rise. So it's 6 volts.
Yeah.
And then you keep moving.
Mm-hmm.
So you have a rise. This is your reference location. Any rise, you put plus in front. Any drop, you put minus in front. This is the way you simplify according to KVL. So you have 6 volts.
Mm-hmm.
This is drop, minus 10. This is rise, plus 14. And then you simplify the number. You have 20 minus 10 equal, oh, sorry, 10 volt.
Yeah, that's what I was trying to say.
Sorry. Yeah, 10 volt. I put 10 volt here. Yeah, 20 minus 10 is equal to 10 volt. So You eliminate this one, you eliminate this one, you go to the location of your reference and put them both. By the way, in series circuit, you can bring this source and place it here. Doesn't matter because it's series. Remember, in series circuit, you can always switch location. This is the way that you simplify bunch of independent sources. When you have, you can even combine dependent source, but I usually prefer not to combine dependent sources, leave them alone. But independent sources, you can combine voltage sources as long as they are connected in series. As long as they are connected in series. Any question about this example?
Yes, so if there were no polarities assigned, we could assign our own and they could be like
Yes.
all positive or all negative if we wanted to.
You can assign, I mean, usually when they give you voltage sources, they give you polarities. For boxes, you can assign. For passive element, you can assign polarities. Anytime problem has a source, they give you polarities or direction.
Right.
But if you have passive elements, you have to assign polarities. And then you can assign anything you want.
So they could be all one sign or the other, right?
Yes, yes, yes.
Okay.
Okay, important observation. Let's assume that we have the following case. Let me go to this time Aguilar.
Yes.
Okay, in this case, how can I combine? Can I combine? First question is, I have 3 voltage sources. In order to simplify my future calculation, I want to get rid of too many voltage sources, independent sources. Is it possible to simplify them?
Well, you have a parallel, so shouldn't
I
I
don't,
just
I don't have any parallel in this case. I don't have any parallel to elements in this case. Where do I have parallel?
isn't those 2 elements parallel,
Which 2 elements?
2 and 3?
How 1, 3 you see as parallel? What's the definition of parallel?
Definition of parallel is elements are in parallel, voltage is the same, and series.
No. Elements in parallel. What's the look, appearance of parallel when you see parallel elements? The voltage across V3 is the same as 1 because you said they are parallel. Do they have same common nodes? Didn't I say that for parallel, elements must have same nodes? Do you see 1 and 3 to have the same nodes?
No.
They're totally unrelated. There is no 2 parallel elements in the circuit. Even 2 and 3, they are not in parallel because 2 and 3, they are apart by a 4 volt inserted in the middle. So even 2 and 3, they are not at the same level. There is no parallel element here.
So you could simplify this by
I don't see that.
No, wait. I'm asking. Okay.
No, I'm saying that I don't see it either, too.
Okay. So parallel is out, and I haven't even discussed how to combine parallel. You don't combine voltages when they are in parallel because if they're in parallel, they carry the same voltage. I'm talking about combining. I have 3 independent sources. The question is if I can combine them. And if I can combine them, if the answer is yes, how do I combine Alejandro? Santiago, are you here? Alejandro, are you here? This is also taking role. Third time, Alejandro, Amador, Henry. Henry, Amador.
I'm here.
Okay, is it possible to combine these sources, yes or no? And if yes, how?
I think yes.
Okay, how do I combine?
Adding up the voltages and taking the direction into account to make it positive or negative.
Okay, you give
That'd
me the
be
number, so
20 volts positive,
okay,
3 volts negative,
okay.
and 4 volts positive.
Okay, let me go to next person. Arilano, do you
Here.
agree? Do you agree?
I believe that you would first have to combine the 20 volt and the 3 volt and then make them into 1 volt. And then you combine the other two because the first two that I was telling you.
Okay, first, let me follow what you're saying. So you say I'm combining 20 and 3, which is 17 volts. Where should I place this voltage source?
I think you could like combine them and put them on the left, like you said in the last.
Yeah,
right?
because as soon as you write the first voltage, that's a location. So it's going to be the location here. So it's going to be 17 volt, and then you delete this one because you have already combined it. Anytime you combine, you get rid of it. Okay, 17 volt. Okay, now you say we should continue to do what?
Well, now that the sources aren't in series though, right? Because there's a
No,
third.
they are not. Yeah.
So you can't combine them?
So you stop. That's it. You cannot combine 17 and 4 volts. There is a middle element here. These two are not in series. You can only combine them if they are in series. If they are not in series, you can only combine the series one. If they are apart, if I had another one in series with this one, I could combine it at the other end. But I cannot combine. Cannot combine 17 volts and 4 volts because they are not in series. Okay. Any question?
Professor, I have
So-
a quick question. Oh, go ahead, man.
Sorry, you go ahead.
Professor, I have a quick question in regards to the 17 volts. Is it because he started on 17 and he went?
Because I started on 20.
Oh, I see.
Remember, we had 20 here,
Right.
and we had 3 here, right? So if you start from here, you're the one that you choose the source, unless if they tell you in the problem start with 20 volt. If the problem doesn't say anything, you have the option. So you started here. If you start here, this is your reference. So at the end, it's going to be your location and your polarity.
I guess
And then
what
you
I'm trying
have, yeah.
What I'm trying to ask is why did you subtract if you're not?
Because okay, look at here. Once you select this one, how many sources we have in series? Only 2.
2.
This is your reference. Okay, move in any direction. I mean, in this case, probably clockwise direction is easier.
Right.
So move in clockwise direction, rise, drop. So it's going to be 20 minus. So just use the word from minus to plus, 20 plus to minus, opposite, minus 3. When you go through 20 volt, it's a rise. When you hit 3 volt, is what? When you're moving. How do you go through 3 volts? From plus to minus, which is the opposite. That's why it's minus. Yeah.
Let's see. Okay, thank you.
So we couldn't bypass anything here?
Bypass what? Sorry.
Like, you know how you're learning about bypassing in the last session?
No. That bypass is current source. It's current. It has nothing to do with voltage. No.
Okay.
Yeah.
I have a quick question, Professor.
Yeah.
If component number 2 would have been a voltage source, could we have added that or subtracted?
No, you can't. Again, that's a good question. Let me show you. If the component number 2 was a voltage source, let's say whatever. Again, voltage source A, voltage source B, voltage source C, voltage source D. A and B are in series. C is not in series or parallel with anything. D is not in series or parallel. Why? Because you have essential node here. Think about like you have a current coming here. Current doesn't stay the same. Current is divided. Anytime you have essential node, anytime you have a node with 3 or more elements in the middle, then series option is out.